example 5, and in this example I want to show you the model prediction for second order systems. In this example, the input is the electrical heating power, so the U, and the Y is the temperature in the heat exchanger, and K is a coefficient that can be changed for different cooling methods. So the starting state value for the temperature U and heating power U are 300 degree and 1200 watt. And now the heating power increases from 1200 to 1500 watts at time 0, and then we want to calculate the time profile of Y for K equal to 2, 4, 8, 3 different values. So before we do the simulation in Simulink, we change the model to the deviation form here, and then after that we perform the Laplace transform, and then you're going to get the transfer function, and then actually this one is transfer function, right? Transfer function, and it's second order model, and then we change the transfer function in the standard form, right? Standard form, the constant term in the denominator should be 1, right? So we divide 4 in the numerator and also in the denominator, and then we get the standard form, right? So before I show you the result of the output for different K values, I want to show you the prediction, like before we plot the profile, and we could predict whether the output and has oscillation or not, right? So we could compare, for example, here we compare coefficient for the second order and S square, right? Then we could see this to be equal, so therefore tau square equal to 1/4, so tau equal to 1/2. But actually I made this example from the homework, so I think you might get familiar with this example. So, and similarly, K/4 should equal to K/4 is the coefficient for the S equal to 2 tau eta, right? And then because eta equal to 1/2, so we put eta into here, right? This eta, so we will get K/4 equal 2 times 1/2 times eta. Actually, this is tau, right? So we could get eta equal to K/4, right? So you could see the eta value for different K value. So for different K value here, because eta equal to K/4, right? So it should be, so the eta value for these 3 K values should be 2/4, right? Less than 1, so it should have oscillation, and this one should be 4/4 equal to 1, no oscillation, right? The another one is 8/4, right? It's 2 larger than 1, and so therefore we should not see oscillation in the last 2 profiles, but we should see the oscillation in the first profile. Now I want to show you okay, so firstly we work on K equal to 2, right? So we're going to put the transfer function here, so K equal to 2, right? The step change, right? The step change is 300, right? The magnitude is 300, right? 1500 minus 1200 is 300, right? So step change is 300, and then initial value is 0, and then the step time is 0. Okay, see here. So this is how we set up step. Okay, now let's put this in the Simulink. So we go to get we build a new Simulink 5 new model. Right, so we close this one for the example 4, and then you could input the transfer function here, continuous, and transfer function, move it here. Again, we need to zoom in, right? And then zoom, make this windows bigger. Transfer function, right? And then double click. Then the coefficients for the numerator is 1. The denominator should be 1, 2, and 4. And then we could make the step sources here. The step here should be here. The step should be step times 0, initial value 0, final value 300, right? So this is for and for the first step. And again, right? Because the output from the transfer function here is y prime, right? It's y prime. Okay, so this is y prime. So therefore, you need to add the y over bar, right? Our y over bar is 300, and then this one you get y because we want to get a temperature, right? So we need to add this. Go to the constant, go to the sources, and go to the this is constant. Put 300 here, and then you go to the math to add the summation operation here. Summation. Okay, add them together. Okay, that's it. So we save the output. Again, similarly, we save output in the workspace and scope, and also we're going to use the display to see the steady state value. Okay, see. Move this around. Then I forgot to save it. Save the document as example 5 simulate. Right, link them, and then change the name here as so. We compare the 3. We compare the simulation for 3 different cases, right? So the first one we change the name as y1. Again, change the array format. That's it. Save it. Then you could run simulation. Actually, the simulation time should be 15 minutes, right? Let's see. So the simulation time here should be 15 minutes. So therefore we set the simulation time to 15. I save it, then run it, and then you see in the scope, you see profile, right? So you can see oscillation. It seems correct to me. Okay, now let's move to the k equal to 4 and k equal to 8. Now I want to show you a approach that an easy approach for you to do the job, because you can see for k equal to 4 and k equal to 8, and the module is similar to the one k equal to 2. So you just select the module, and then you use Control C or Control V and make a copy, or you could just push the press the Control key in the keyboard, and then use the mouse to draw this and module around, and then you get them and the copy. Okay, so for example, now you could get the copy here. This one we change the k for k equal to 4, right? So we change 2 to 4. That's it. And this one, and then we say the output as y2, right? Make sure that the format is in array. And similarly, this one we change k from 2 to 8, right? And then change the output here as y3 and format as array. And then at the same time we need to add the time signal here, so we add the clock here. Okay, and then we say so we copy a workspace here, but change the time, the variable as time, right? And then just save it, Control S. So you could click here, save it, right? I think we already done with this and model. Run a simulation, and then you can see we get the simulation result for y1, y2, and y3 for 3 different k1, k2, and k3. Now our job is to plot them out, plot these 3 profiles together. So this the module already developed. Now we need to plot them together. So we go to the MATLAB and the Win and the desktop for the MATLAB. So here we get, since you just put plus, you add a new script. Then just type plot y1 as red color and light with 2, right? And then you hold on, because you want to put several curves together. Well, and then you could just copy, right? Copy, and then another copy, because you have 3 curves. Then change this one to y2. The color is blue color. And then this one's y3. The color is black color. K represents black color. And then almost done. And then add S label. S label. Here is the time, minute. Okay, and then the font size here is 12. Okay, and then you could copy this one for the Y label, and then just Y label and change the time, change the here is Y, and here's the so this is the superscript. Always superscript right degree. This one, okay, I want to show you. This means what? This means superscript. Okay, but only always superscript. If you want to C become superscript, you only need add O and then C. Okay. And then so this is the Y, is the output temperature, and then you put the legend here, and then you can get here K equal to 2, K equal to 4, and K equal to 8, and the font size here you could just copy font size here is 12. Okay, save it. You will change other font size. Okay, this change it to model 5, main model 4. So we get main example 5. Now just type main example 5. Okay, and then you should get this profile. Okay. Similarly to the profile we have here. Good. So we are done with example 5.